Okay, YouTube, in this video, this is my second example of graphing a limacon, or any function of the form r equals a plus or minus b times either sine or cosine. I'm just going to write a cosine up here of theta, okay? So we're basically going to construct this graph using some basic characteristics of the shape, but starting with this, we want to determine what kind of shape this has. So in this case, we have r equals 4 minus 4 sine theta. Let's try to conclude as much as we can about this, starting with the fact that a, in this case, our a value is 4, and our b value, just because it's got a negative in front, doesn't matter here, we're going to say is 4. So in this case, we would say that a over b, this is what we're really checking out. Recall that if a over b is less than 1, it'll refer to our loop. If we have Lou loves dimpled cuties here in that order, so we say Lou goes with loop. Love, we have this heart-shaped thing, this is a cardioid. It's a cardioid, and we say that this is true if a over b is equal to 1. If we have a over b is between 1 and 2, then we have this dimpled thing, dimpled, sorry about my M there, and then we say if a over b is greater than or equal to 2, then we have a convex shape. So I notice in this case, if we do a over b, we get 4 over 4, which is equal to 1. So in this case, we're going to have a cardioid that we're going to be sketching here. So let's start with this. It is a limacon of the cardioid type, heart-shaped type, okay? So in terms of the maximum r value, remember that you're always going to obtain a maximum r value of whatever a plus b is. So in this case, we have a is 4 and b is 4. We're going to get a maximum r value of a plus b is 4 plus 4 is 8. Okay, and then we say number of zeros. Well, looking at the scheme here, you'll notice that we're going to leave from 0 and we're going to come back around and get to 0. So I say a couple of zeros here. In terms of representing points here, we're always going to do 4 points, and these are going to be the points of the quadrant angles here. So I should say like maybe 5 points, because we'll start at 0 and go by pi halves increments, and I'm actually going to stop at 2 pi. I'll include that one here. So we say 3 pi halves, and then 2 pi. So let's go ahead and plug these into our function. We say, okay, well, plugging in 0, think about your unit circle here. We say, what is our sine value at 0? So we get sine of 0 is 0. And then if we were to say 4 minus 4 times the sine of 0, which is 0, we would get, well, 4 minus 0. So this is 4. We would say at pi halves, our sine value of pi halves is 1. So we would say 4 minus 4 times 1 would give us 4 minus 4. So we get an output of 0 here. If we plug in pi, we say, what's our sine at pi? Well, at pi, we would say sine is 0. So we get 4 minus 4 times 0, which is 4. So we get 4 here. At 3 pi halves, interesting thing happens. We get a negative 1 for a sine value. So we actually get 4 minus 4 times negative 1 here, which 4 minus 4 times negative 1 would be 4 plus 4, so we get 8. And then what's going to happen is it's going to roll back to 4 again because we arrive at a sine value of 0 again. Okay, so we get back to that 4. So when we put this together, we're just going to put all these points on the graph here. First thing I know also is this, I'd say it's a sine graph, so it's going to look like it opens up or down. And also this, because it's a sine graph, it's also going to have symmetry over this vertical axis. So let's go ahead and plug in our points here. We say r is 4 when theta is 0, so we're going to go out 4. Or sorry, we'd say at 0 radians here. It looks like we go 1, 2, 3, 4. Here we go, 4. We say at pi halves, we have a 0, so here's a 0 here. At pi, we go out 4 units in that direction, 1, 2, 3, 4. And then at 3 pi halves, we're going to have to use the power of imagination here. We say 1, 2, 3, 4, 5, 6, 7, 8. So here's our 8. And then at 2 pi, it comes back around to 4 again. So we get this graph here. And one thing we want to keep in mind is essentially this. We had a negative b value. So this is going to be like our cardioid graph, but instead of going around and opening upward, kind of folding out upward, it's going to open downward. So we're going to have to use our best graph sketching abilities here. But what we get is this curve that folds out, opens downward, and is symmetrical about the vertical axis, and we get this thing right here. I do want to point this out right there. We get what we call a cusp. This is a cusp. This is what makes it heart-shaped. But here's our heart-shaped thing. It opened downward. Its maximum value is 8. We see right here. This is 8 comma 3 pi halves. And, we just plugged in a battery of values here to kind of determine its basic graph shape. So in the next one, we'll graph maybe one of the dimpled or the convex types. Cheers.